Good afternoon, folks. We are back again learning about energy modeling. We are using the SketchUp extension for OpenStudio. Today, we are going to be learning how to implement a simple photovoltaic system. We will also run the model, look at the results, and make some comparisons. A photovoltaic system is a system capable of converting solar energy into electrical energy, explaining it in a very basic way. Our aim here is to use this type of system on our model. To begin, let us first prepare a surface to receive the photovoltaic system. We cannot use any surface. For this user script, we will be applying the PV to a shading surface. Our first step is to use the Create Shading Surface Group tool right here. Select in the model a surface to apply the shading element. It will be our PV system. Validate or edit by pressing the Enter key. We will not draw the PV system. The shading element should have the same shape as the photovoltaic system. So when you think about your photovoltaic system, think about its shape when you are drawing it. To simplify the progress of this video, we will not discuss optimal orientation, that is, the best orientation for capturing the most sunlight. We have created the shading element. It is important that this dark purple tint is facing outward. If it is not outward, it is necessary to invert. If necessary, select the face, right-click, reverse faces. We will extrude our surface to a box to give it some depth. Alternatively, you can use a Move tool to position the surface a little higher. Okay, now we will assign the PV system. Select the shading group and select the surface. Go to Extensions, OpenStudio User Scripts, Alter or Add Model Elements, Add Photovoltaics. We have a dialog box with three options. The first option is choosing a load distribution center. It is the control center for metering and managing the PV system. We do not have a distribution center, so it is necessary to create it. Leave this as default. The second option describes how much of the surface is covered with photovoltaic cells. As shown on the screen, the value is specifying that 100% of our shading surface group is covered by photovoltaic cells. If we only assign 50%, the value to be specified would be 0.5. The program would understand that only 50% of the system would occupy the shading element. We will leave the default value, 1. That is 100%. The third option tells us about the conversion efficiency of the PV. The conversion of solar energy into electrical energy is not 100% efficient. It does not convert all of the sunlight into electricity. The default efficiency is 20%, 0.2. Depending on the manufacturer, the percentage of efficiency can be different. We will leave it as a default. Click OK. You can see now that the photovoltaic system is assigned to the building. In the model, this system could be in any position. But strategically it is positioned on horizontal surfaces or even with a certain angle. This will capture the most solar radiation. The next step is to simulate. We open the model in OpenStudio and run the simulation. Save it, and we'll evaluate the simulation results. Click the Launch OpenStudio button. We are going to add a report measure to be able to evaluate the energy produced by the photovoltaic system. How much electric energy is consumed by the building and how much is generated by the PV. For this model, simple internal loads were used, such as lighting and electrical equipment. They are there so we can test the photovoltaic model. The measurement report is already added. We are using the International Measurement System, Philippines version. Let us run the simulation. We were successful in our simulation. Let us evaluate the report. According to the building summary, we see our model has a total demand for electricity. There are internal loads that are generating this demand, total site energy. Let's look at the renewable energy source summary. This is electricity produced by the photovoltaic system that we added. Where the photovoltaic system would occupy 100% of the shading element, and it has 20% efficiency. The system is capable of generating an electricity equivalent to 9,816 kilowatt hours per year. This results from the characteristics that we had assigned in SketchUp. We can also see in the Site and Source Summary guide. Here we have the electric energy demand of the model. Below, we have the net site energy. It is a difference in energy consumed and produced. The energy being consumed minus the energy generated from the photovoltaic system. Of course, we will not find exactness in values if we do the calculations. There are distribution and energy conversion losses. These losses add up from the PV array to the electrical wires to the DC-AC conversion, and finally the reactive losses going to the electrical grid. These factors are used to estimate approximately. They are good, in general, reliable estimates. We are now going to change the characteristics of the photovoltaic system and reevaluate those numbers in the report. Let us memorize this amount of electricity produced. This generated value corresponds to 100% of shaded area is solar cells, and they operate at 20% efficiency. We will change these values. Go to Extensions, OpenStudio User Scripts, Alter or Add Model Elements, and remove photovoltaics. First, let us remove the existing system. Click Yes to remove it completely. We are now going to assign a new photovoltaic system. Let us change the fraction of the photovoltaic plate. Efficiency will remain at 20% so that we can compare with numbers we already have. Click OK. Save the model and reopen it in the OpenStudio application. Now let us simulate again. We were successful again. We will evaluate the report. The system generated 4,908 kilowatt-hours of electrical energy. This value corresponds to exactly half of the energy produced that we had previously. As we reduced the photovoltaic system by 50%, we also reduced 50% of the electricity generated. And that is exactly what was expressed in this report. We will now work with efficiency. By default, the program uses 20% efficiency. We're going to increase the efficiencies to obtain new values of electric energy. Again, we are going to edit. Every time you edit, you need to click on the surface and remove the existing system as we did previously. It allows you to deploy a new system. This time, we are not going to touch the fraction of the area, but the efficiency. We will add an additional 20% efficiency to our system, resulting in an overall efficiency equivalent to 40%. We click OK and save it. Reopen it in OpenStudio. You can search for the file or just use Revert to Saved. And we have it opened again. Recall that we are investigating the influence on the efficiency variable of the photovoltaic system. We will run the simulation again. Simulation finished. Let us evaluate the results. Go to the Renewable Energy Source Summary. And we observe that the value of electric energy produced is now approximately 19,600 kilowatt hours. In the first simulation, when we had simulations with the characteristics of 100% area fraction and 20% efficiency, we obtained a value of 9,816 kilowatt hours. Realize that the power generation has increased, and this increase is justified by the 20% increase in efficiency that we used this time. It is clear that our changes affected the simulation. So that is basically it. It is the way to add photovoltaic systems to energy models. There are many factors to be analyzed when designing a photovoltaic system. The SketchUp OpenStudio user script allows you to easily customize the dimensions and simple performance parameters of a PV system. It will allow you to quickly evaluate the performance of a photovoltaic system. I thank you all, and I ask you to subscribe to the channel, enjoy the videos, and don't forget to click on the notifications to receive whenever we post new videos. Thank you. Please like and subscribe.